Let's dive into how pirates found their way without GPS, before digital maps showed a blue line telling sailors exactly where to go. There was only the ocean. Endless, changing, dangerous. A pirate could leave a harbor in the Caribbean and sail for weeks without seeing land. No GPS, no phone, nothing telling him where he was. And yet, some pirates could cross enormous stretches of ocean and return almost exactly where they intended. How? The answer was not magic. It was knowledge. Knowledge passed from sailor to sailor, from captain to navigator, from one generation of seamen to the next. And if you were standing on the deck of a wooden pirate ship hundreds of years ago, you would have learned very quickly that the ocean was not empty. It was full of clues. The first clue was the sun. Every morning, sailors watched where it appeared on the horizon. The sun rose in the east. It traveled across the sky and disappeared toward the west. That simple movement gave sailors a basic understanding of direction. But experienced navigators wanted more than direction. They wanted to know where they were. So they watched the sun carefully. At certain times of day, they could measure its height above the horizon using instruments such as a cross staff or quadrant. The measurement could help them estimate their latitude. That meant they could determine roughly how far north or south they were. It wasn't perfect. The ship moved, the waves rolled, the deck tilted. Clouds could hide the sun, and a small mistake in measurement could become a large mistake after many days at sea. But sailors learned to make repeated observations. One measurement could be wrong. Several measurements could tell a much clearer story. Then came another essential tool, the compass. A magnetic compass did not tell a sailor exactly where he was. It told him something equally important: direction, north, south, east, west. A captain could give an order, keep her west, and the helmsman could maintain that general direction even when there was no land anywhere around them. But even the compass had problems. Magnetic north was not exactly the same as true north. The difference varied depending on location. Sailors had to understand magnetic variation if they wanted their navigation to remain accurate. And then there was the most important thing of all: the stars. At night, the ocean became almost completely black. The horizon disappeared. The ship became a tiny wooden shape floating beneath an enormous sky. But above that darkness, the stars remained. In the northern hemisphere, one star was especially important: Polaris, the North Star. It appears close to the North Celestial Pole, making it extremely useful for determining direction. But it offered something more. Its height above the horizon could help a navigator estimate latitude. The closer you traveled toward the North Pole, the higher Polaris appeared. The farther south you traveled, the lower it appeared. So a sailor could look at the sky and gain information about his position. The ocean itself had become a map. The stars were the markings. The horizon was the edge, and the navigator had to learn how to read it. But there was another problem. What if clouds covered the stars? What if the sun disappeared? What if the compass became unreliable? What if the ship had been sailing for days and the crew had no idea exactly how far they had traveled? Then sailors used something called dead reckoning. It sounds mysterious, but the basic idea was simple. You start with a known position. Then you keep track of your direction and speed. If the ship travels west for several hours at a certain speed, you estimate how far west you have gone. Then you do it again and again. You record the changes. Over time, you build an estimate of where the ship should be. But the ocean had a way of ruining calculations. Currents could push the ship sideways. Winds could change its course. Waves could slow it down. The crew might misjudge their speed, and every small error could accumulate. After several days, the ship might be much farther from its estimated position than anyone realized. That was why experienced sailors watched the environment constantly. They watched the waves, the wind, the clouds, the color of the water, birds, floating vegetation, and eventually, land. A skilled navigator understood that the ocean was always communicating. A change in the water could suggest a nearby current. Certain birds could indicate that land was not impossibly far away. Floating branches or vegetation might have come from a distant shoreline. None of these clues were perfect, but navigation was rarely about one perfect clue. It was about combining many imperfect clues. The compass pointed one way, the stars confirmed another. The estimated distance suggested another. The wind explained why the ship had drifted. The current explained why the calculations were slightly wrong. Together, they created a picture. And there was one final secret. Pirates did not necessarily need to know their exact position every second. They needed to know where they were going. That difference mattered. If a captain knew the latitude of a destination and could maintain a reliable east-west course, he could make a long ocean crossing without ever seeing the destination until the final stage. The journey became a constant cycle. Observe, measure, estimate, correct, sail. Then observe again. It was exhausting. It required skill, and it required patience. Because one mistake could send a wooden ship hundreds of miles away from where the crew expected to be. But the most frightening part was still ahead. Knowing where you were was only half the battle. Because once the sun disappeared, once the clouds covered the stars, and once the ocean swallowed every familiar landmark, the navigator had to answer the most important question of all. How do you know you're still going the right way? The answer was hidden in the movement of the sky, and in a tiny instrument spinning above a wooden deck. The tiny instrument above the wooden deck was not magic. It was a compass, and for sailors crossing an enormous ocean, it could mean the difference between reaching land and disappearing forever. You stand on the deck of a wooden ship in the middle of the night. There is no coastline, no lighthouse, no road, no sign telling you where you are. Only black water stretching toward the horizon. The captain looks upward. The stars are visible again. He searches for Polaris. There, almost perfectly north, he checks the ship's heading. Then he checks the compass. The two pieces of information work together. The ship continues. This was how navigation worked for sailors who had no GPS. Not with one miraculous invention, but with a collection of observations. The sky, the sea, the wind, the compass, the ship's speed, and memory. A navigator might carry charts showing coastlines, islands, reefs, shoals, and known hazards, but a chart could not tell him exactly where the ship was every moment. That had to be calculated. One of the most important ideas was latitude. If you knew how far north or south you were, you had already solved half the problem. The stars helped, so did the sun. During the day, navigators could measure the altitude of the sun. At night, they could use known stars. Over time, navigation instruments became increasingly sophisticated. The sextant, developed later than some of the earliest tools, allowed sailors to measure the angle between a celestial object and the horizon with impressive precision. But even the best instrument could not remove every danger. Clouds could hide the sky. Storms could last for days. The sea could push a ship away from its intended course. That was why dead reckoning remained important. A navigator kept track of the ship's estimated speed and direction. Imagine you begin at a known location. You sail west for 10 hours. You estimate your speed. You record the course. Then the wind changes. You adjust. A current pushes the ship south. You estimate that too. Hour after hour, the navigator builds a moving picture of the voyage. The calculations were never perfect, but they did not need to be perfect every minute. They needed to be corrected regularly, and experienced sailors learned another valuable skill. They learned to recognize places before they arrived. A coastline had a shape, an island had a silhouette, a mountain could rise above the horizon, a harbor could have a distinctive entrance, a dangerous reef might be marked on a chart. Even the color and movement of water could provide clues. Then there were the winds. Sailors learned prevailing wind patterns. They understood that certain regions of the world had winds that behaved in recognizable ways. They could plan voyages around them. A ship wasn't simply pointed toward its destination and forgotten. The crew constantly adjusted. Sails were trimmed. The course was corrected. The navigator compared observations with expectations, and the captain made decisions. That is the part modern travelers rarely imagine. A GPS receiver gives you a position almost instantly. A navigator at sea had to build that position. It was a process. Observe the sky, read the compass, estimate speed, account for currents, check the chart, look for landmarks, make a calculation, then check it again and again. The ocean demanded attention, but there was one final advantage sailors possessed: experience. A veteran navigator could recognize things that a beginner might ignore. He could look at the clouds and understand what kind of weather might be approaching. He could feel a change in the wind. He could recognize a familiar current. He could identify a coastline from a distant shape. He could remember a route he had sailed years before. This knowledge was valuable. It was often passed from one sailor to another, and mistakes could be deadly.